A body that is in flight after it is thrown or projected is called a projectile. The motion of the projectile is the result of two separate but simultaneously occurring components of motion. One is the horizontal component without any acceleration, and the other is the vertical component with constant acceleration due to gravity. We neglect the effect of air resistance on the motion of the projectile. The initial velocity of the projectile is v0. Initial angle of projection with the x-axis is θ0. The horizontal component of the initial velocity v0 x is v0 cos θ0. This horizontal component remains constant throughout the flight, as the acceleration in the x direction is 0 and air resistance is negligible. The vertical component of the initial velocity v0y is equal to v0 sin θ0. This vertical component keeps on changing with its position and lapsed time of the projectile. As the vertical component of the projectile motion has an acceleration equal to the acceleration due to gravity. Here, A is equal to minus gj. Ax is equal to 0. And Ay is equal to minus g. Consider the origin is at the initial position of the projectile. Therefore, x0 and y0 is equal to 0. Now, let's find the position coordinates of the projectile at any time t. Consider the horizontal motion x is equal to v0x into t. On substitution, we get x is equal to v0 cos θ 0 into t. Let this be equation 1. Similarly, vertical motion can be written as y is equal to v0y into t plus half at square. On substitution, we get y is equal to v0 sin θ0 into t minus half gt square. Let this be equation 2. Now, we can write the components of the velocity of the projectile at any time t. Vx is equal to v0x, which is equal to v0 cos θ0. As the horizontal component, Vx always remains constant. As the vertical component of the projectile has acceleration equal to minus g, it keeps on changing with time. Hence, Vy is equal to v0 sin θ0 minus gt. Now, let's write the equation of the path for the projectile. By eliminating t from equations 1 and 2, we can get the equation for the path of the projectile. From equation 1, we can write t is equal to x divided by v0 cos θ0. Let this be equation 3. Substituting equation 3 in 2 and simplifying, we get y is equal to tan θ0 into x minus g divided by 2 into v0 cos θ0 square into x square. Let this be equation 4. In this equation, tan θ0 and g divided by 2 into v0 cos θ0 square are constants, as g, θ0 and v0 are constants. As you know, the equation of a parabola can be written as y is equal to ax plus bx square. Let this be equation 5. In this equation, a and b are constants. By comparing equations 4 and 5, we can conclude that the path followed by a projectile is a parabola. Let's now find the time taken for the projectile to attain maximum height. At the top point, momentarily, Vy is equal to 0. Substituting Vy is equal to 0 in the equation, we get the expression as shown here. Tm is the time taken to attain maximum height. Therefore, we can write Tm is equal to V0 sin theta 0 by g. Let this be equation 6. Now, let's find the time of flight of the projectile. Time of flight is the total time during which the projectile is in motion. When the flight ends, y is equal to 0. If Tf represents the time of flight, then Tf is equal to time of maximum height plus time of descent. By the symmetry of the path of the projectile, which is parabolic, and time of maximum height is equal to time of descent. Therefore, Tf is equal to 2Tm. On substitution, we get Tf is equal to 2V0 sin theta 0 by g. Let this be equation 7. Next, we will find the maximum height attained by the projectile. Consider the maximum height of the projectile as h meters. This height is reached in time Tm. Substituting in equation 2 and simplifying, we get h is equal to V0 sin theta 0 square divided by 2g. Let this be equation 8. What is the horizontal range of the projectile? Here, the initial position of the projectile is 0, 0. The final position of the projectile is x, 0. X is known as the horizontal range, r, of the projectile. This is the horizontal distance travelled by the projectile during its time of flight, Tf. On substitution and simplification, we get r is equal to V0 square into sin 2 theta divided by g. Let this be equation 9. What is the angle of projection for the maximum range of the projectile? R will be maximum when the sin 2 theta value is maximum. That is, 2 theta is equal to 90 degrees. Therefore, theta is 45 degrees for r to be maximum. Let this be equation 10. Substituting theta equal to 45 degrees in equation 9, we get r max is equal to V0 square by g. The equation of the path for the projectile. Y is equal to tan theta 0 into x minus g divided by 2 into V0 cos theta 0 square into x square. Time taken for the projectile to attain maximum height. Tm is equal to V0 sin theta 0 by g. The time of flight of the projectile. Tf is equal to 2V0 sin theta 0 by g. The maximum height attained by the projectile. H is equal to V0 sin theta 0 square divided by 2g. The horizontal range of the projectile. R is equal to V0 square into sin 2 theta divided by g. The maximum range of the projectile. R max is equal to V0 square by g.